Welcome back to Cosmic Compass. Here we explore the wonders of the universe, one story at a time. From distant planets to the mysteries of cosmic phenomena, we ask the questions that bring space a little closer to home. Today, let's dive into a challenge that could decide the future of human exploration growing food on Mars. We've seen it in movies, but how possible is it really? Let's imagine standing on the rusty surface of Mars. The horizon stretches endlessly barren and silent. Now picture yourself hungry, knowing that the only way to survive is to grow your own food right there in alien soil. Could we really do it? Many of you may remember the film The Martian, where astronaut Mark Watney survives by planting potatoes in Martian soil. It's a clever solution in fiction, but how practical would it be in reality? Does Martian soil actually contain the nutrients plants need? And even if they grow, would it be safe for us to eat them? Surprisingly, Martian soil does contain many of the essential elements for plant growth, though this depends on location. Just like Earth, where some soils are rich and others barren, certain areas of Mars would be more suitable for farming than others. However, Martian soil is not really soil in the way we know it. It's regolith crushed rock that has never been enriched by worms, insects, or decaying plants. It's sterile. To test how this might affect crops, researchers in 2016 planted tomatoes, rye radishes, peas, spinach, quinoa, and even chives in a simulated Martian soil here on Earth. The results were remarkable. The plants grew almost as well as they would in regular Earth soil. For comparison, the same crops were tested in imitation lunar soil. Yields, they dropped to about half, but they still grew, with spinach struggling the most. This shows us something important. Plants are surprisingly adaptable. There was, however, a key detail. The scientists had to mix organic matter into the Martian soil simulant, in this case cut up grass. This acted as fertilizer, added nutrients, and helped the soil retain water around the roots. Without this, the plants would have died quickly. So the first barrier we face is clear Mars lacks organic matter. Any farming effort will need fertilizer, and lots of it. But fertilizer is only part of the challenge. The bigger problem is that Martian regolith contains toxic compounds. Among them are heavy metals, and most concerning, a salt called calcium perchlorate. Why is this a problem? Because plants naturally absorb what's in the soil. A lettuce grown in Martian regolith would draw perchlorate into its leaves. It might look fresh and healthy, but hidden inside is a toxin that can damage the human thyroid if consumed in large amounts. Imagine taking a bite of a crisp Martian salad, not knowing it could be slowly poisoning you. Yet here lies a paradox. The very compound that poses a danger could also help us survive. Perchlorates are hygroscopic. They pull water straight out of the thin Martian atmosphere. That water could be collected and purified for human use. Even more remarkably, perchlorates can release oxygen when broken down. On a planet where oxygen is scarce, that is an invaluable resource. So while dangerous, these salts might one day serve as part of our survival toolkit. From this, we can see two major obstacles to farming on Mars. The lack of organic fertilizer. 2, the toxicity of perchlorates. The first challenge might be easier than it sounds. In The Martian, Watney used human waste as fertilizer. In reality, raw feces would be dangerous because of pathogens, but if it's sterilized and processed, it can safely be used. Over time, compost from old plants and food scraps could also be recycled, creating a sustainable system. The second challenge, removing perchlorates, also has potential solutions. One method is simple: wash the soil with water to rinse the salts away, then recycle that water separately. Another idea is to introduce bacteria that naturally feed on perchlorates, breaking them down and releasing oxygen as a byproduct. In both cases, the soil becomes safer and nothing goes to waste. Now let's step back for a moment. Why go to all this trouble to grow food on Mars? Couldn't astronauts simply bring dehydrated meals from Earth? Fresh food is more than just nutrition. Studies show that crops like tomatoes, blueberries, and red lettuce are rich in antioxidants, which could help protect astronauts from radiation in space. Just as important, imagine the psychological boost of biting into something fresh and alive after months of eating packaged meals. That sense of normalcy, of connection to life back home, could be vital for long-term missions. We already know that plants can be resilient. They've grown successfully in Mars simulations on Earth, and even aboard the International Space Station. The real test, though, is whether they can grow safely in the actual conditions of Mars. So can we grow plants on Mars? The answer is yes, but with careful preparation. Fertilizer must be added, and perchlorates must be removed or neutralized. The science is promising, but one critical question remains: will Martian crops be safe to eat? The only way to know for sure is to try. One day, when the first seed is planted in Martian soil and sprouts a leaf toward the weak sunlight, it will mark more than a scientific experiment. It will be the first step in making Mars not just a place we can visit, but a place where life can truly take root. Thanks for watching Cosmic Compass. If you enjoyed this journey into Martian agriculture, don't forget to like the video and subscribe for more explorations of space and beyond. What other cosmic questions would you like us to tackle next? Let us know in the comments. Your ideas help guide where we go together. Until next time, let's keep looking up, because the universe always has more stories to tell.